A very good afternoon, everyone. Welcome you all to this online NPTEL discussion class on Industrial Inorganic Chemistry. I am Madhuri Bhattacharya, Prime Minister Research Fellow in Department of Chemistry at Madras. So this course has been originally taught by Professor Devashish Rai from Department of Chemistry, Indian Institute of Technology, Kharagpur. So here we are discussing regarding some important industrial inorganic compounds, their utilization, purification, production, etc. So today we will discuss regarding some construction materials, enamels, ceramics, these materials. So these are my details and email IDs. You can contact me for your any query or clarification. And today we will cover these things like some construction minerals, enamels, ceramics, compounds we will discuss today. So coming to the first question, what is the difference between hydraulic bonding agents and air bonding agent? Both harden in air, both harden in water, or hydraulic bonding agents actually harden in air and water, but air bonding agents harden in air. So this is the correct answer actually. Okay, hydraulic bonding agents will harden in both air and water, but air bonding agents will harden in air only. So all the bonding agents in organic substances harden in presence of air and water, and they will bind the pieces of stones. But hydraulic bonding agents are those which harden in both air and water, like cement. Cement can harden in presence of air also, and if we add water, then also. Like after cementing the wall, we will often wet it by using some water. We will often wet it and then keep it for some days. We will soak it with water so that its strength will be enhanced, so it will bind more compactly. So that is why hydraulic bonding agents can harden in both air and water, but air bonding agents will only harden in presence of air only, like calcine, gypsum, CaSO4. Okay. Then what is the silicate modulus? Silicate modulus is actually the ratio of silicon dioxide to the sum of alumina and your iron oxide, like ferric oxide. Sorry, this is ferrous oxide, Fe2O3. So ratio of silicon dioxide to alumina and ferrous oxide is called the silicate modulus. And silicate modulus, if it is too high, then cement sets slowly. High silicate ratio means there are more calcium silicates present and less alumina and ferrite. So silicate ratio should be typically in between 2 to 3. This is the acceptable silicate ratio. Then what is the correct formula of efringite? Efringite is a special mineral formulation having this formula: 3 calcium oxide L2O3 and 3 calcium oxide or 32 H2O. So this is actually calcium sulfoaluminate, which is normally found in Portland cement concretes. So Portland cement concretes, which is used for construction of buildings, will have this calcium sulfoaluminate, 3 calcium oxide A2O3, 3 calcium sulfate and 32 H2. After mixing cement powder with water, part of tricalcium aluminate and gypsum will dissolve and react together, forming efringite. The formation of efringite is in fresh and plastic concrete is the mechanism that controls stiffening. Okay, so this is responsible for stiffening of cement. Now, what is the clay content in clay ceramics? Clay content should be in clay ceramics greater than 20%, because ceramics are generally made by taking mixture of clay, earthen element, powders, water, shaping them into desired forms. So once ceramics has been shaped, it is fired in higher temperature oven known as kiln. Then it can be divided into two types: clay ceramics and specialty ceramics. In clay ceramics, the clay content is more than 20%, whereas in specialty ceramics, clay content is less than 20%. Clay ceramic material can be divided into coarse and fine materials also. Fine ceramics means particle size will be smaller, like less than 0.2 millimeter in size, but coarse ceramics have higher pores or crystal size. Then zirconium oxide is a type of actually oxide ceramic as well as specialty ceramics. So zirconium oxide is obtained by the mineral zircon, that is zirconium silicon tetroxide, and it is a part of specialty ceramic product only. Oxide ceramics are obtained from single phase metal oxides. Here the raw materials should be very pure. Like for example, here zirconium silicon tetroxide zircon should be very pure. It should not contain any impurity. The applications will include furnace construction, resistive heating elements, neutron refractors, etc. Then what kind of ferrite is cubic ferrite? It is actually soft ferrite, because ferrite is a ceramic material made by mixing and firing large proportions of iron 3 oxides blended in small portions of one or more additional metallic elements such as strontium, barium, manganese, nickel and zinc. Ferrites can be of two types. Cubic ferrite, it is a kind of soft ferrite. It is used in recording and erasing the head of tape recorders, ferrite antenna, and hexagonal ferrite is a hard ferrite type. It is used in DC motor alternators, magnetic igniters, magnetic couplings, etc. Then the next question is about which of the following is non-oxide ceramics? Silicon carbide, silicon nitride, boron nitride. So all do not contain any oxide, and these all are actually non-oxide ceramics. So non-oxide ceramics are covalently bonded ceramics which results in high thermal conductivity and low values of thermal expansion, right? High thermal conductivity and low values of thermal expansion. Non-oxide ceramics does not contain any oxygen, no oxygen at all in the crystal structure. These products exhibit a range of amazing products including hardness, resistance to corrosion and heat, compressive strength, and here silicon carbide, silicon nitride, boron nitride, all are examples of non-oxide ceramics which are very stable at high temperatures. Then next question is about alkyl silane. Which product we get by chemical vapor deposition of alkyl silane? Alkyl silane and then chemical vapor deposition we are doing. So the product will get beta sheet structure of silicon carbide. Chemical vapor deposition is a vacuum deposition method to produce high quality and high performance solid materials. Chemical vapor deposition process produces beta silicon carbide by thermal decomposition of alkyl silanes or dichlorosilanes in plasma or flow reactors above 1000 degrees centigrade. Very high temperature is needed, and then vapor deposition and vacuum will be, vacuum means there will be no pressure, right? So we will apply the vapor deposition and then silicon carbide will be formed. Then this reaction, silicon dioxide, carbon and nitrogen gas. What will be the product? Product will be actually silicon nitride, because this is a chemical compound of elements of silicon and nitrogen. This is most thermodynamically stable of silicon nitrates. Si3N4 is the most commercially important silicon nitrates where when referring to the term of silicon nitride, because this, and also this is formed by carbothermal reduction. Carbothermal reduction means reduction by carbon applying some in presence of some heating source. So carbothermal reduction of silicon dioxide in nitrogen atmosphere at 1400 to 1450 degrees centigrade will produce silicon nitride. And this is very important. Non-oxide ceramics. This will have good thermal expansion, good thermal conductivity, as we have discussed in this question. Then moving to the next question: how many layers of enameling are possible? So only 2 layers of enameling are possible, because enamel is an opaque hard substance to protect from corrosion and increase the aesthetic appearance of the materials. Enameled steel surfaces produce high corrosion protection. Enameling is a process by which the powdered glass is fused with a metal substance at high heat. So there are 2 layers of enameling are possible. One, a ground coat to bond the substance, and another one is to cover. It is a cover coat to provide the desired external properties. So these are all about ceramics. Okay, some ceramics and enamel construction materials we have discussed today. In the coming class, we will discuss about some carbon modifications, like some carbonization, graphitization, some different forms of carbon, then some inorganic filler material, and yeah. then we will discuss all those things in the coming class. So that's all for today. Thank you.